Just like with icons, we often want to include images in our user interfaces. There are two main approaches to do this. One is to load an image from the internet using its URL, which fetches the image each time the user interface is rendered. The other is to bundle the image within the project so it can be used offline. To load an image from the web, we can use the image.network constructor. The only required parameter is the image URL provided as a string. Additional parameters let you customize the image's appearance, such as its size, alignment, or how it fits its container. This method is simple to use, but it's important to make sure the image is accessible at the given URL. Bundling an image with the app is a bit more involved. First, you need to create a folder in your project, commonly named images, to store all the images you plan to use. The folder name is your choice, but must be created manually. After placing the image files inside this directory, you must update the pubspec.yaml file. This file serves as the app's table of contents. If you don't declare the external assets here, the app won't be able to access them. The pubspec.yaml already has a section for assets, but it's commented out by default. You need to uncomment it and list each file or folder you want your app to use. Simply adding a file like polimi.jpg to the images folder isn't enough. You must explicitly declare it in pubspec.yaml for the app to load it correctly. This code example shows a simple standalone app that displays an image stored in the images folder we set up earlier. Aside from the typical app structure, the key difference is that the child of the center widget is now an image. The constructor requires an image as its parameter, which in this case is provided using the assetImage class, indicating the image is bundled with the app. The image widget supports popular formats like PNG, JPEG, JPG, GIF, BMP, and WebP, and can even display SVG files on some platforms with the help of the Flutter_SVG package. The two UI examples show the difference when running the same code before and after adding the asset to the pubspec.yaml file. Although the code remains unchanged, the outcome varies drastically because the app cannot access the image until it's properly declared in pubspec.yaml. Now that we have a solid set of building blocks, we can start creating something a bit more advanced and hopefully more engaging. We will stick to a single screen app, but this time we will draw inspiration from the default Flutter app generated by Flutter Create. Instead of a classic counter example, we will add a few new features. First, we will include a slider to set the increment value, ranging from 1, the default, up to 5. We will also add two separate buttons to increase and decrease the counter by that amount. The counter should never drop below 0 or exceed 100. If an increment or decrement would break these limits, it should be ignored. While the app's basic structure remains familiar, this will be our first time working with a slider. So we will need to understand how it functions and carefully manage the counter's state to ensure correct behavior. Here we have different independent code snippets which should now be clear and easy to understand. The first three lines define the class managing the counter state and its two state variables. Counter, initially set to 0, holds the current count, while increment starting at 1 represents the step size for changes. Next, we create the slider widget, which appears at the top of the interface. The slider has min and max values defining its range, and the divisions property that sets the number of steps between these values. Here, the range is from 1 to 5, and with 4 divisions, each step changing the value by 1. The value property reflects the current slider value initialized from the state variable. Since value expects a double and our variable is an int, a conversion is needed. Similarly, the label property shows the current value as text, so the integer is converted to a string. The onChanged callback runs whenever the slider moves, triggered by user interaction. Since we have one slider and 2 buttons, there are 3 callback methods. Here we highlight 2: decrement counter, which subtracts increment from counter only if the result stays at or above 0, and set increment called when the slider changes, which updates increment a double to set the step size. The increment method mirrors a decrement counter, but it increases the value and is not shown here. As noted, all state changes must be wrapped in set state to keep the UI and state in sync, causing Flutter to rebuild the widget tree and reflect the updates. You can find the full version in additional materials. To create a variation of the previous app, we can swap the slider for a text field. A text field is a widget that lets users enter text input. This slide shows one way to use it. By default, if left unconstrained, the text field will stretch to fill the entire horizontal space. To limit its width, we wrap it in a sized box, which in this example sets a fixed width of 100 points. We center the user's input by setting text-align to text-aligned.center and control the font size with a text style. The onChange parameter specifies a callback triggered each time the user modifies the input. Inside this inline callback, we use try_parse to convert the string input to a number, since a text field always returns text. The double question mark operator handles invalid input by returning the parse number if successful or 0 if not. In the next and last lecture, I will show how to create a realistic app, a simple calculator.